Okay, welcome to your example in section 10.5 on separation of variables, heat conduction in a rod. So what we're going to do here is solve the heat equation where L is 40 and the initial heat profile is given by this function. This function can be seen to be just this sort of TP function over the interval 0 to 40. Okay, so the heat initially has a maximum in the middle of 20, and then it's fixed at 0 at the ends. The general solution here, so we just used the regime that we had in the previous lecture, is going to be given by this infinite series of exponentials multiplied by sine functions. The coefficients are these Fourier coefficients for our f, which, because the function is piecewise defined, will be split into pieces. And what we end up with is this nice collection of coefficients, and only when they're odd. Okay. So what we can do here is we can plot the solution in 3 dimensions for various n's. So what I did is I took the first 100 terms of the Fourier series here and plotted the solution. So notice right about here, this is when t is 0, or t is roughly 0. And so what the solution does is immediately smooths out. So remember, there was a corner in the initial condition of the solution right away. The solution immediately smooths out, and then it stays sort of symmetric, but it eventually, as t goes to infinity, it eventually declines. And what we'll see here is the presence of the negative exponential functions means that u will always go to 0 as time moves on, because the heat leaves the rod in such a way that the boundaries are still equal to 0. And so we get this really interesting, essentially symmetric solutions for each time that all decay to 0 as time goes to infinity here. So this is a pretty nice example of what you see. Okay, thank you.